Yesterday that, converting a fraction to a decimal is simple as setting up the division problem, doing the bar, and just figuring it out. And obviously, if you have a calculator, you can just type in, for example, 3/4. The calculator will tell you it's 0.75. Going the other way, okay, requires a little bit of work, a little bit more time consuming, but actually, I think it's pretty cool. It kind of reminds me of a puzzle. So I'm going to do 6 examples today. I'm going to give you step-by-step procedure on exactly how to figure out what the fraction is.
Does this involve algebra?
It involves a little bit of algebra. Not anything crazy. Well, you still got some variables in pre-algebra. 0.15 to a fraction, okay? And on the worksheet, it's going to say in simplest terms. Also on this lesson, we want to simplify the fraction all the way down. Okay? Just make sure you follow along. Make sure you write down each one of these steps. We're simply going to take the decimal that we're given and we're going to set it equal to x. So what I'm going to write for step 1 is x is equal to 0.15. Okay? Again, that's one of those steps, like if you get to the homework or the assignment and you say I'm confused, I don't know anybody in this room that can't write x equals whatever. Okay? That's why I'm giving you these steps. Sometimes you forget what to do. If you have the steps written down, it reminds you of what to do. Okay, the next step we're going to do is to determine the decimal place. Okay, so what I normally do is I look at the original fraction and I draw, I'm basically going to move that decimal as far to the right as possible. So how many times did I have to move that? Twice, okay? So we are in the hundredths place, okay? The way you would read that decimal is 15 hundredths. Does that make sense? If I move it once, it'd be in the tenths place. Move it twice, hundredths, 3 times, thousandths, whatever, okay? So that's it for step 2. You're actually just you're starting at the decimal and you're counting how many of those hops there are. It's actually 2 hops, right? It'd be two total hops. So since it's 2, we're going to multiply both sides by that many zeros. Okay, 1 followed by that many zeros. 2 hops means we're going to multiply both sides by a 1 with 2 zeros. And it might take you a few examples to catch on to this, but I think you're going to see what's going on here. If we'd move the decimal 3 times to the right, we would multiply by 1,000. If we just move it 1 to the right, we'd multiply by 10. Okay? Again, it's going to take several examples. But what happens is the left side, nothing's going to change. But the right side basically just gets rid of the decimal. So another way you could write step 3 is get rid of the decimal. 100 times 0.15 is the same thing as what we did up here. We moved it all the way to the right. That's just 15. Okay, so the goal of step 3 is to get rid of the decimal. And now we just have a simple, very simple algebra problem. Does anybody know how to get x by itself at this point? Divide, yeah. So for step 4, we're going to divide both sides by the coefficient of x. The coefficient means the number in front of the x. So in this case, it's 100. Now, why do we divide by 100? Because it cancels out. Okay? The 100 on the left are going to cancel. And we get x is equal to 15 over 100. Perfect, yes, good observation. That leads us to the 5th step. Once we divide both sides by the x coefficient, we're going to simplify the fraction. Perfect, so we're going to divide the top and bottom by the GCF, which we've already learned. But we can look at this until it's going to be 5. Final answer is 3 over 20. So if we rewrite the original problem, 0.15, it's equal to 3/20. That's the fraction. Perfect. Then go ahead and do it. Do you know any of these, Roy? So what would you do? All right, well, I'll check it later and see if it works. Okay? Number 2, convert 0.25 to a fraction. Some of you already know this one, right? It's what? 1/4. Yes. Okay, but if you didn't know that, you're going to do the same thing we did before. So we're going to have x for step 1 is equal to 0.25. Now, in this example, we actually move the decimal the same number of places. We move it twice. So we're going to be multiplying both sides again by 1 followed by 2 zeros. Remember, the number of zeros here is determined by the number of times you move that to the right. And whatever you do to one side, you have to do to the other. So, like this. Okay, and when you do that, the decimal will go away for this one, and it'll just end up being 100x equals 25. Okay, and now we're going to divide both sides by the number next to it, which is 100. So we get x is equal to 25 over 100. All right, now all we have to do is figure out the GCF of those two, which happens to be 25. Yes?
Pretty much all we're doing at the beginning is figuring out what number the denominator is.
Yeah. Yeah, right.
Shouldn't you be able to just figure that out in your head, like say?
Yes, you can. Some people can't.
It's like 125, you put that over 1,000, right?
0.125? Yep, 125 over 1,000. And just reduce it. If you want to do it that way, it's perfectly fine.
Like a 1,125, you'd have to put that over 10,000.
Yeah, good. Yep. Now, when you get to repeating decimals, it's not quite as simple. But yes, for decimals that don't repeat, it works. 25 over 25 is 1. 100 over 25 is 4. And that's it. So the decimal for 0.25 is 1/4. Okay, obviously they're going to get a little bit more difficult. Let's do 1.25. Okay. Keep putting the decimal in the same place. I know I've got a few that aren't in this place, but again, you can notice for step 1, you're just going to x equals 1.25. Okay, easy enough. This one is still, you'd have to move it twice to the right in order to move it all the way to the right. So therefore, you're going to multiply both sides by 1 followed by 2 zeros. Okay. So you get 100x equals 100 times 1.25, which is just going to move the decimal all the way to the right. So you get 100x is equal to 125. Divide both sides by 100. We get x is equal to 125 over 100. All right, what's the GCF of 125 on 100? Anybody? 25, good. So divide the top and bottom by 25. What's 125 over 25? 5, right? And 100 over 25 is 4. So the final answer is 5/4. So that means that 1.25 is equal to 5 over 4.
So we can do them, I do some almost like,
No. That would be an improper fraction, which is fine because the lesson is just converting to fraction. It doesn't have to be proper, improper. It doesn't have to be mixed. Certainly we could do a mixed number. Okay, let's do this one. This one's in a different decimal place. How many times do you have to move this decimal before it goes out to just once, right? So what are you going to multiply both sides by? 10, good. You're going to have 2.4 is equal to x. We're going to multiply both sides by 10. I put the x on, well, it's not really the wrong side, but it might as well be consistent. X equals 2.4. So we get 10 times x is equal to 10 times 2.4. All right, so we get 10x equals, decimal goes away for that step, 24. Divide both sides by 10. X equals 24 over 10. All right, how do you reduce that? Is it just 2? Yep, you're right.
Yeah.
Final answer? Yes?
Okay, so whatever the,
It would be
we just have to find out the top number.
12 over 5. So therefore, the original one, 2.4, is just 12 over 5. But yeah, you got to reduce it once you figure out what that bottom number is. Okay.
I remember the now.
So I did this one because the decimal place, you guys are making good observations. This is going to move once, twice, 3, 4 times. So that number will be 1 followed by 4 zeros, okay? Which is 10,000, right? That's why I show my work. I mean, I know some of you want to try to avoid as much work as possible, but the reality is, why not show it? I don't understand why you wouldn't if you're more likely to get the answer right. So x is equal to 0.0625. Since we moved that 4 times, we know we're going to be multiplying both sides by 10,000 because it has 4 zeros. Okay? So it's going to be 10,000x is equal to, I'm going to have to show this in a different way, 10,000 times 0.0625, which it doesn't matter because the decimal is just going to go away. So we're going to have 10,000x is equal to, does anybody know what 10,000 by 0.0625 is? Basically, the decimal is going to go away. Yeah, good, 625. The 0 in the front doesn't matter, right? I mean, it just becomes 625. All right, so now we're going to divide both sides by 10,000. Whoops. And maybe that is the hardest part, is simplifying the fraction, because certainly we don't want to leave it as 625 over 10,000. There are definitely ways to simplify that. I don't necessarily know what the GCF of those two is, but I can look and tell that what number goes into both. Actually, yeah, you're right, 125. I was thinking just 25, but 125 I think actually will work. Let me double check. Yes, I think you're right. Let's divide by the biggest one. Certainly you could divide by 25 and then just keep simplifying, but since he pointed out that, we will go ahead and divide both by 125. 625 over 125. I think it's 5, right? All right, so we're going to have a 5 on the top. This one's harder. 10,000 over 125. Well, guess what? I know that 125 goes into 1,000 8 times. So it goes into 10,000 80 times. Or actually, see 8, hold on a second. 8 times 125 is 1,000. Yeah, 80 times. 80 times, yes. Okay, now here's the thing. I can actually go ahead and simplify this even more. The top and bottom have a 5 in common, right? So 5 over 5 is 1 on the top. 80 over 5 is 16. So that means that 0.0625 is equal to 1/16. If you can keep going, just simplify it all the way. So tell me, how would do you have a method for this one as well? Or is it just for like the simpler ones?